Hi, welcome to Algebra 2, Lesson 2-2, Standard Form of a Quadratic Function. In this lesson, we'll be able to write and graph quadratic functions in standard form. And the lesson vocabulary is obviously a standard form of a quadratic function. So let's start with looking at this critique and explain question. Jordan and Emery are rewriting the vertex form of the quadratic function y equals 2 x minus 4 squared plus 5 in the form y equals ax squared plus bx plus c. This form we have looked at in a prior lesson in our vertex form of a quadratic function. In examples 4 and 5, we had to write the vertex form in this form, and I did mention that this was a standard form, but the textbook didn't go over the proper name for this. Okay, so today in this lesson, we'll be able to identify this form as a standard form and think about this form. So Jordan has this function written in vertex form, right? And then wrote the form in ax squared plus bx plus c. And Emery started with the same equation, but has a different form at the end, 2x squared minus 27. Which one is correct? So part A, did Jordan rewrite the equation correctly? Did Emery correctly? So yes, these two are the same, right? But the first equations are same. Let's check the second equation. Is this the same as this? Can we do that? Can we multiply 2 out here? And is this the same as this? X minus 4 times x minus 4 is x squared, right? So that would be x squared and then minus 4x minus 8x plus 16. So, I'm not sure about that either. So, I don't think any of them are correct. Look at Jordan. If it were 2 times x minus 4 without the square, yes, you could distribute it and say 2x minus 8 would be the same thing, but you can't just ignore the square. You have to solve the square first and then multiply them by 2. You can't you can just ignore the order of operations, right? So neither Jordan nor Emery is correct. Because they didn't follow the rules of the operations, and they're wrong. The second step is wrong. So what is the correct step? So we can say that x minus 4 squared is x squared minus 8x plus 16, right? So then we can say the next step would be y equals 2 times x squared minus 8x plus 16, right? So plus 5, yeah. And so y is equal to 2x squared minus 16x plus 32 plus 5, and then you can simplify that to y equals 2x squared minus 16x plus 37. So we can write neither. Whoops, what did I do? So let me type. I'm gonna type neither Jordan nor Emery is correct. The correct equation is, and then I'm gonna write. The correct equation is y equals 2x squared minus 16x plus 37. Okay. So in other words, Okay, so part B, without rewriting the equation, how could you prove that Jordan or Emery's equations are not equivalent to the original? We just talked about it. The second step, Jordan cannot ignore the order of operations, so he needs to solve square first. Emery did solve the square first, but x minus 4 squared is not equal to x squared minus 16. X minus 4 squared, it would be x squared minus 8x plus 16. So we already know by looking at their second steps. Let's write that down. We can say that neither student squared the binomial correctly, and that was incorrect. Jordan distributed the 2 before squaring the binomial, and Emery didn't even square the binomial correctly. Okay. All right. So we have to make sure that we know how to square the binomial correctly in this lesson. It's an easy mistake that we could all make. So let's just remember that the order of operation is important and you need to square the binomial correctly. So essential question, what key features can you determine about a quadratic function from an equation in standard form? We'll continue with example 1 in the next video.